All right, today what we want to talk about are polynomials. Up to this point, we've been talking about monomials. And so what polynomial is basically a sum of monomials, each term of a polynomial. Some polynomials are binomials, some are trinomials. So when we see this table here, we can go ahead and look at the expression 4y minus 5xc, and we can say that this is a binomial. It has two monomials within the expression. When we see negative 6.5, we would say yes, it is a polynomial because it's a monomial, okay? Monomial is in the family of polynomials. When we look at 7a to the negative third plus 9b, because it has 7a to the negative third is 7 over a to the third, that is not a monomial. Remember, we cannot have a variable in the denominator and call it a monomial. And then finally, 6x to the third, 4x plus 3. You would say, okay, it has 1, 2, 3, 4 terms in the expression, but remember, we want to combine our like terms. And so it ends up being 4x to the third plus 5x plus 3. That's why we can call that a trinomial. All right, so when we talk about a degree of a monomial, the degree of a monomial basically is the sum of the exponents of all the variables, all right? So when I look at 2d to the third minus 5c to the fifth d minus 7, okay? When I look at this, I can say the degree of 2d to the third is going to be 3. Basically, it's just its exponent. Not that fancy. When I see 5c to the fifth d, the degree is the exponents of just the variables. So c has an exponent of 5, d has an understood exponent of 1, so the degree of that would be 6. Constants do not have a degree, okay? We just basically say they don't have a degree. So when we're talking about, so that's where we were just figuring out degrees of monomials. When we're talking about the degree of the polynomial, what we're doing is we're taking the greatest degree of any term in the polynomial. Because it had the greatest degree of 6 for 5c to the fifth d, that's why we say the polynomial. The whole polynomial up here has a degree of 6. Okay. These are just some basic things that it's nice to know. So when we talk about standard form of a polynomial, let's talk about how we write these and how we write them correctly, okay? Basically what we do is we look at the greatest degree and put it in order, okay? Our constants basically get placed at the end. So if I'm looking at this first one here at 3a, I would rewrite it in standard form as 4x to the fourth minus 2x squared minus 3x. See how basically my exponent of my x values is going down. And then finally plus 8. Go ahead and this next expression, please write that in standard form. We'll look at it in the next class. Okay, so now what we want to do is we want to add polynomials, all right? What we need to remember is adding like terms, okay? That's all it really is. So I'm going to go ahead and look at it in standard form. I'm going to start with my largest exponent beside my x value, and I have 5x squared, and I have negative 3x squared. I'm just taking a look at just those. 5 minus 3, I get 2x squared. X squared is just coming along for the ride. Next thing I have is I have my negative 3x and I have positive 6x. So negative 3 plus 6, that's where I'm going to get 3x. And then finally I have 4 minus 3, constant goes at the end, so I would have plus 1. And that's all I'm doing when I'm adding my polynomials together. Go ahead and try the next one on your own. Next, I want to subtract polynomials. Now, the only real major thing that you need to remember when you're subtracting your polynomials is, so you don't get confused, remember our rules for adding integers. If I said 4 minus negative 7, I would change it to a 4 plus positive 7. Remember that rule, adding the opposite? So we just want to use that rule and add, change that minus sign to a plus sign, and I want to add, and that's going to become a positive 2x to the third. That's going to become a negative x squared, because we're adding the opposite, and this would be a positive 2. Okay, that's all we're really doing when we're subtracting. If you do that, then really you're just adding the polynomials. So again, we're going to go by degree, going from the largest degree and working our way down, and I have 4x to the third, and now I have positive 2x to the third, so I get 6x to the third. Those guys are done. Sometimes it's easier to cross them out so you don't make mistakes. I have negative 3x squared and negative x squared. So that's going to be a negative 4x squared. That guy's done. That guy's done. And then I have a 6x. There's nothing to combine it to in the other polynomials. So all I'm going to do is just write plus 6x. And then I have negative 4 plus a positive 2. So I end up with a negative 2. And that's it. Go ahead and try the next one on your own. Next thing we're going to do is we're going to multiply a polynomial by a monomial. Now there's a couple ways that you can do this. I'm going to show you both methods. The one method that we can do is we can take negative 3x squared. It's called the horizontal method. I'll do negative 3x squared and multiply it to 7x squared. And then I can do negative 3x squared and multiply it to negative x. And then I can take negative 3x squared and multiply it to 4. So I end up with an answer saying negative 21x to the fourth. A negative times a negative is a positive 3x to the third. Negative times a positive is a negative 12x squared. Okay, I can't do anything else with it. There's no like terms to combine. That's all I can do with it. So now I want to go ahead and do the vertical method. I have 7x squared minus x plus 4. And I'm going to multiply it by negative 3x squared. So negative 3 times 7 is negative 21. X squared times x squared is x to the fourth. Negative 3 times negative 1 would be positive 3x to the third. X squared times x is x to the third. Plus, nope, I'm sorry. That would be minus, because a negative times a positive would be negative 12x squared. I get the same answer either way. These are just two different ways of being able to solve it. All right, here's a couple practice problems. All right, first thing I have is I want to simplify this expression that I have. So basically, I'm distributing 2p to everything there, and I'm going to distribute negative 5 to everything there. So I end up with, let's see, 2 times negative 4, I get negative 8p to the third. Okay, p times p squared gets me p to the third, plus 2p times 5p gets me 10p squared. Then I have 5 times 2p squared, negative 5, so that's going to be negative 10p squared. And then 5 times 20 gets me negative 100. Now, I have these like terms here in the middle. So that means I can go ahead and cancel those out. All right, a positive 10p squared and a negative 10p squared cancels each other out. So the answer I end up with is negative 8p to the third minus 100. All right, this looks really big and huge and daunting, but I promise you it's not. What we're basically doing is we're going to go through and distribute everything, okay? So 2a times 5a is 10a squared. 2a times negative 2 is negative 4a. What I've just done is that. Okay, next thing I'm going to do is distribute the next. 3a plus 2a, that's plus 6a squared. 3a times 6 is going to be plus 18a plus 8. All right, it's going to equal. So I just distributed this and got this part, and then plus 8. I just added that guy at the end. A times 4a, I get 4a squared plus a. A times 1 is just a. I'm going to do the next part. 2a times 6a is 12a squared. 2a times negative 4 is negative 8a. And then finally, plus 50. Let's combine our like terms, okay? If you're thinking that this is horrible, I promise you it's not. It's just a process, and I swear that's all it is. I'm going to combine my like terms on either side of the equal sign. So I have 16a squared, okay? Negative 4a and 18a gives me 14a plus 8 equals 16a squared. A minus 8a is negative 7a plus 50. Let's go ahead and start doing some stuff. I have positive 16a on both sides. If I subtract one, they're going to cancel each other out. So I'm left with 14a plus 8 equals negative 7a plus 50. Just plain old algebra, plain old simple canceling and moving around. Add 7, I get 21a equals, I subtract 8, I get 42. And a equals 2. All right, last. I'm going to have you do this one on your own and see what you bring back to class. I will get you started. I'm going to multiply negative x squared times z to everything in here. So when I do that, negative x squared times z times 2z squared, I get negative 2. All right, that negative sign goes to the 2. There is no other x, so I say x squared z to the third. Okay? Now I have negative x squared z times 4xz to the third. So that's going to be negative 4x to the third z to the fourth. Okay? I've just taken care of this part. Go ahead, distribute, and then once you're done distributing and expanding it, then start combining your like terms, and we'll see what your answer is in class. Thank you.